So in the last session, we have discussed about like how to pass data to variables, class variables. So we have seen different ways to pass data into the class variables. So as part of that, we have seen like using the object reference variable, we can pass the data, and using user-defined methods and also using constructors, we can pass data to class variables. And also we have seen differences between method and a constructor, right? So now in this session, we'll see more on polymorphism. So before polymorphism, let us understand one concept called call by value and call by reference. This is important in point of view of an interview mainly. We are not going to use this mostly, but this will be helpful for the interviews. So what is call by value and what is call by reference? So let us understand directly with an example. This is related to methods and method calling. So let us understand that concept using an example. So I'm creating a new package. I'll name it as day 12 and we'll create a new class. So I'll call my class as test method. I know I don't need a main method in this. We are going to create a main method in a different class. So this is my test method. And then we'll have some integer as a class variable. And then we'll create a method where I'll say modify value. I'll modify it and then I'll just say value in the method. All right. So what did we do here? We created a class. We created a class variable inside the class. We have a class variable and we have a method in it, which takes one parameter, integer parameter, right? So after taking that parameter, right? After reading that parameter inside the method, we are modifying the value of the number of the parameter whichever has been received as part of the method call. And then we are just displaying it on the console. Okay. Now let's create another class. So I'll call this class as call by value. Where we'll have a main method. So what we usually do, I wanted to call this method. So this method is in a different class, right? So we need to create a object for that class, right? So test method, new test method. So this actually creates an object of the test method class, right? All right. So now we have an object and we can actually access this number, right? So this method, right? So what we can do here is I'll create another number here. So I'll say int number equal to some 10. Okay. Or some 100. Okay. And then we'll just say int num equal to 100, right? So we wanted to call the method. So I'll call tm dot modify value of 10 of num. Num in the sense 100 in this case, right? So this, what happens? We know that. So when we call like this, using the object of test method, so the modify value method gets invoked or called, right? And this gets, and the logic, whatever the block of code inside the method is, so that gets executed, right? So if you observe, this method is not returning anything. It is void, right? But it is accepting one parameter, integer parameter, right? So this is what we are trying to do know, right? So before value, before the method call. So before method call, what's the value? And value after method call. Both are same statements, right? So we wanted to see what will be the number value. As we are calling this modify value method and passing this number, so inside the method, we are modifying the value of that number, right? So we wanted to see if that change reflects on the right side as well. Right side in the sense in the main method. So that is what we are going to try now. So right click, run as Java application, and you see value before method call is 100, value in the method is 100, and value after method call is also 100. So whatever data type, whatever value we have passed it to the method, so the method call, so the method was called successfully as expected, fine. And this, you know, the number has been copied into, num has been copied into n here. So n is when we call it as local variable to this method modify value. So it is not a class variable if you observe. So the modify value has its own local variable. We call it as its own local variable, and that variable is not visible to the method, sorry, class, right? So this uh, n, which is the integer data type, is local to this modify value method, right? So what happens here is this num, whatever we are calling, is copied into this n. So this n also will have 100 in this case, right? So inside the method, n is incremented by 10. So that is, it has to be 110. That's the reason you can see value in the method is 110. Fine. Now, once the call is done, so once the method is done, so it control comes back to the main method, right? So in that case, it will say value after method call is also 100 because the original value, right? So one original value still remains 100. It is num and it still remains the same. So even though we passed on to this method and the value was changed, that change was only made local to that method, right? So this is because we are actually passing the parameter as a primitive data type. If you observe, num was an integer which is a primitive data type, right? So whenever we pass a primitive data type to a method, so whatever changes has been done to the parameter passed. So this we call it as parameter or argument, right? So whatever we pass it to a method, that's called parameter or an argument. And whenever we pass an argument or parameter to a method, and if there are some changes made to that parameter within the method logic, then those changes are not reflected back to the back or not reflected to the original value. So original value, what is the original value? Num is the original value which you are passing to the method. So there will won't be any changes to that method, any changes to that primitive data type value, right? So this is what we call it as call by value. Call by value, right? We can even call this as, you know, let's call this as original now, just to have more clarity, right? So original and number we are passing, and then we are actually trying to see if the value has been modified or not. So you can clearly see that the value has not been modified. So this is because we have passing to the method a primitive data type. So when we pass a primitive data type, only a copy of it will be sent to this parameter, right? So when the method call happens, so a copy of this original will be passed to the parameter. So as this is only a copy will be changed, and the changes will only be local to this method, but will not actually reflect the original number, right? So this is what we call it as call by value. This is call by value. Now, let me create another class where we'll actually call that class as call by reference. We'll call that as call by reference. Yeah, Umesh. So call by value, call by reference, right? So I'll copy or no, the same. code here and we'll modify wherever it's required. All right, so what is call by reference? I have method here. So I have a class, I have an object created for test method. Fine. So, and now I don't want it to call the same method. I'm gonna create a different one. So I'll call this as modify object, right? And this is gonna take one parameter, which is of type test method. This is test method, okay? And then we'll actually modify the test method now, meaning t dot number. Yeah, other than that, like almost everything will be same except modify value, and then we'll pass the object to it. And this method is modify object. So what did we do here? We created another method. So it is n. Okay, this has to be t dot now. Okay, so what did we do here? In this new class, which is we named it as call by reference, if you observe. So everything was same, but we just added a new method called modify object. And instead of passing the primitive data type, this time we are passing the reference, object reference, right? So we are passing the object reference. So TM is the object reference, right? So when we say new test method, an object gets created in memory of the type test method. All right. So now this will be the object reference. This object reference has been captured in TM, called TM, right? Variable called TM. And we are using this TM to call the method, newly created method, modify object method, right? TM dot modify object, and we are passing the same object to this method called modify object. So what should happen now? This test method, this modify method is accepting a parameter of type test method class, right? So it is accepting an object, not a primitive data type like integer, string, or char, right? So it is actually accepting an object of type test method. This is the reason we are having the parameter of modify object like this test method, and we are capturing it into some object called t, right? So this tm, whatever we are passing, what is tm here? Tm is an object of test method class, right? That reference, that object reference, we are passing it to modify object, right? Now, what should happen? So this TM, so even here, like we have to actually name it as, it's not a version number, but in the TM in the sense test method dot num 100, right? So we are actually passing the data to this number from the test method, and then we'll display this value, test method dot number, right? So what happens here? We created an object and we actually have an object of test method. So we can access its class variable and its method using this object. For now, we are using its member variable, class variable. And then what did we do? We assigned a number to it. Fine. Now we are interested to see that value. So anyway, we assign this value. So it will be the same, right? So this is fine, value before method call. Now, the interesting part here is, so when we call this modify object method and pass this TM is an object of test method class, right? So what happens? The object reference has been copied here, right? So the object reference has been copied. It's not like a primitive data type where the copy has been sent, but the actual, the actual object reference will be copied. Meaning, so the object here is sent as is to here because this is an object reference. The same object reference has been sent to this modify object method now. So this T holds the object reference. So this is same as TM here, whatever object has been created here, right? So now what we are doing inside the method, what's our logic? Our logic is to, so this T is representing this object TM now. So tm and t both are actually representing the same object reference in the memory. Say for example, this is memory, and we created a method, right? So this is the method tm. So this is the object. Say for example, this is memory and this is tm, an object created in memory. Now we pass this tm to modify object test method t, right? So this t also will point. This t will also point to the same tm. Tm is an object in memory, right? So both are same. Now what happens? This t dot num. So tm dot num already has 100 value, right? So this has 100 value as 100. All right. And it is calling modify object method, right? So now the same object reference has been sent here. It's not a copy. It's the same object reference. So because is sent to this method called a modify object. So this t holds tm now. So both tm t is actually pointing to the object called tm. All right. Now if you see inside the method, what's our logic? Whatever is t dot num, add 10 to it is what you are saying. So what is t dot num? T dot num is whatever t is pointing to. It is pointing to tm. Tm, it has number as 100. So 100 plus 10. So t dot new value will be 110, right? So the value in the method has to be 110. And now if we come back, like after the method is done, after the call to method is done, then we are actually trying to print the value after method called tm.num. So tm.num, the new value is 110 now, right? So it has to print 110. And yes, so if you see, that's what it is. Value before method was 100, fine. But value in the method was 110. That is also fine. So you see value in the method, we modified it and we wanted to display it, the new value, that is 110. But value after the method call is also 110 because the changes has been preserved. This is because we have sent the object reference. That's not a copy, but that's exactly the object reference which we are referring here, right? So that has been sent here. So how did we send it? We just pass the object to it. So whenever we send an object reference, so then that object reference, whatever we pass and whatever is capturing it, both will reference to the same object reference, right? This is not like a normal primitive data type. So if it was a primitive data type, then a copy will be sent to the method call. But this time, when we pass the object reference will be copied onto the, so not copy. The object reference has been sent to the method, right? So as the object reference is sent, this object, whichever is capturing it, will also refer to the same object reference. As both are referencing to the same, whatever changes you make to the class member will also be reflected to the original or the original object reference, right? So this is the reason whatever may make changes here in the modify object that are preserved and are reflected to the original object which we created. So this is what we call it as call by reference. As we are passing reference, object by reference, as we are calling a method by reference, right? So we are calling a method by sending an object reference. So this is called as call by reference. As this is the reference, so both, like whenever we pass the reference and the whatever changes we make inside the method on the reference variable that are preserved and are reflected into the original object, which actually called the method, right? So this is what we call it as a call by reference. So because both point to the same object reference, so that's what we call it as object reference, right? So this we learned already. When we create a method, when we create an object in the object for a class, so using the new keyword, an object gets created in memory and an object reference will be written to this object called tm, right? So that object itself we are sending to the method call. So the same object has been sent to the method call and we are making changes to the, using that object itself, we are making changes to the class variable. So the changes will be preserved and will be reflected throughout, like even after the method call, the changes will still be there as both tm and t in this case are pointing to the same object reference, right? So is that clear? This is what we call it as call by reference. important with respect to interview. Interview. This is an important interview question. Is that clear? Am I audible, guys? Okay. Is that clear? So whatever we did earlier, call by value, right? So this is the usual one. Like we know when we do call by value, this is, I think this is clear, call by value. There is nothing new here, right? So what did we do here? We are passing, we created an object. So at least till here it is fine, right? So a class has been created, a class variable and a method. And a method has been created. So there is some logic. Forget about this logic for now inside the method. Now, in the main method, we are creating an object for this test method. This TM represents the object for this test method. All right. We have a separate primitive data type declared within the main method. And then, right, so we are just displaying its value. That will be 100. This is fine, right? Now, we are calling this method called modify value by sending this original number to it. Now, as this is the primitive data type, integer, so a copy has been sent to this modify value object method, right? So inside it, we are modifying its value. So as this is only a copy, the copy will be mod. So this is only a copy. Remember, this original number has been sent to here. So once it is sent here to n, then what happens? N gets the value of original number. Fine. So this will be local to it now. So local in the sense, whatever changes you make within this method are restricted and known only to this method. So you can see here, we are declaring int n, right? So this is a new variable. This is not a class variable, if you observe. Class variable name was a different one, num. But this is the int n. Int in the sense, we are declaring a new parameter, new variable here. And version num has been copied into n, right? So n is a copy now. Number is a copy. That, and we are making changes on the copy, n equal to n plus 10, right? So done. Once the call is done, so if you come back, the original number is still preserved. Only a copy of original number has been sent here. This is the reason the original number has not been changed and original number is still there. If you observe to this within this method, main method, version number is still the same. Only a copy has been sent and some logic has been executed within the method, which is not known to this main method because we are sending primitive data type. So whenever we make changes on the copy of the primitive data type value, right? So that changes are not known to the method call. So wherever we are calling the method, so that method will not know the changes of it. So is that clear till here? This is called call by value. This is called call by value. And now let us see call by reference. So what is call by reference? We create another method and this method is not taking primitive data type if you observe. It is taking a class object as the parameter. We can even pass object as a class parameter, class object as well. So instead of like till now we have seen passing parameter as a primitive data type, integer, string, double like that, right? Now if you see, we are passing an object to this method called modify object, right? Now what we are doing, we created an object. This is fine. Now we are modifying it or we are initializing its value. So TM will have its own copy. TM will have its own copy, right? Its own copy in the sense it will have num, it will have modify value, it will have modify object in its own, right? So for example, say this is memory, right? Now we'll have this is TM object and it will have its own copy in the sense This is TM, object TM, and it will have its own integer num, and it will have modify value. It will have modify object as well. So this is how it will have in its memory, right? So now what happens when we wanted to, so this is the object created. So we initialize the value to 100. So this num will get value as 100. Now, what did we do? Value before method call. So we are just displaying this number. So it will be 100 anyway. So this is fine, right? Now, what are we doing? We are calling this method called modify object. How we are calling? So let us understand till here. TM. TM is the object. So we are calling this method using the object called TM. TM is an object, right? So we are using TM. We can access num, right? We can access num class variable. So we initialize some value. We can access modify value method. We can access modify object, right? Now I am accessing using this object TM. I am accessing or I am calling modify object method. Till here it is fine, right? And I have to pass a parameter to the modify object, right? So modify object is accepting a parameter. That parameter, we wanted to have it as TM, right? So TM is an object, right? So we have passed this TM to this method. So this method will have the reference in the sense this TM whatever we are sending here, this will be not a copy, but the actual reference. Actual reference in the sense whatever TM is referring to. So TM in the is an object, right, in memory. So this is actually has been assigned to T now. So T also will actually T is an object which is also referencing to this object called TM, right? So both T and TM are same now. Now inside this method, T dot num equal to T dot num plus 10, right? So this T is pointed to TM. Both are literally like pointing to the same object reference. So using T also we can modify its value. So it's like almost TM dot num. I can do some modification on it, right? So the same way, like we are passing on it onto some object and we are using that object. Both are pointing to the same object, okay? So T is also pointing to the same object TM. So T dot num equal to T dot num plus 10. We are doing increment, right? So now T dot num using T, we are modifying the value, right? Class variable value. Now it has become 110. That's what we have seen value in the method. This is also fine till here, right? Now, once we are done with the method call, once we come back, so value after method call, we are saying tm dot num, right? So tm dot number. So what is tm dot number? You can see it here in the memory. What happened? Tm dot num. It has become 110 now, right? So we see 110, right? We can see 110 value after method call, right? So this is what it happens. So it is simple. When we pass primitive data type, the original value will not be modified because when we pass primitive data type to a method as a, as a parameter, so what happens? It takes only the copy of it, right? But when you pass an object reference, so the actual object will be sent to the method. So it is the actual object reference. So both the objects are referring to the same object reference. So the modifications which are made to those class variables will be preserved as it is only one copy, as it is only one object reference, right? So the changes will be preserved. So this is what we call it as call by reference. So in order to make you understand clearly, so let me give you an example. So say for example, you and your friend went to a restaurant, right? And you had it, you ordered a dish and you liked it, and you wanted to make it at your home, and you went to that chef and asked him the recipe card. So, and the chef has given you the recipe card, and you took that recipe card, a photocopy of the recipe card, uh, photocopy of the recipe card, right? So you both have two copies now. of the recipe card. So you went to home and you prepared your dish according to that recipe card, and your friend also prepared the recipe dish according to the recipe card. But you might be adding something like if you wanted to, if say for example the dish is cookies and you wanted to add some chocolate chips like that, but your friend wants to add something else to it. So would that reflect whatever you are preparing or whatever you both are doing, right? So would that reflect the actual thing what chef is doing? No, right? Because it's only a photocopy has been given to you. The actual recipe card is still with the chef and he follows the same, right? So the changes, whatever you are making here by looking at the photocopy of the recipe, so will only be known to you, will not reflect to the actual recipe card who has given to you, right? So this you can understand it as call by value. Now, how do you understand uh, call by reference? So, okay, 1 second, right? So this is a, say for example, this is the recipe card. This is the original card, which has instructions, right? Recipe details and how to cook the dish, right? Now, this this is this is held by the chef, and chef actually gives you a copy. Say for example, you brought the copy. So this is only a photocopy of the recipe. Okay, this is only a photocopy, not the actual recipe, right? So now you got the photocopy of this recipe. It's not the same. You got into your home and you're cooking. While doing, you modify some instruction. So according to your taste, you might actually make some changes while preparing the dish, right? So would this copy reflect the actual recipe copy in the chef, whatever chef holds? No, right? Because this is only a photocopy sent to you. And whatever changes you make here will not actually reflect the original copy, right? Original chef's recipe copy, right? So this you can understand it as call by value, right? Now you can understand the call by reference as like, say for example, you have a book from library, right? You're studying, you're a student, and you have a book from library. You bought a book from library, right? And you have gone through it and you have lent it to your friend, right? So this is a book, and so you have lent this to your friend, the same book, right? So you have gone through it for a few days, and then your friend asked you the same book. You shared your book to your friend, right? Now, while go through the book, your friend might take some notes here in the book. He can mark something, right? So he can, if he doesn't like, right, he can even tear the page, right? He can even damage the book, right? So when the book is returned back to you, would that affect you or not? That would definitely affect you, right? Because this is the same book. There is only one book which you have given to share to your friend. And whatever changes are made to that book, whenever it is written back to you, that will affect definitely you, right? Because the same book has been written to you after making the changes. So you'll see those changes, like having some notes, having some markings in it, right? Even some pages might be teared down like that, right? So that changes will you will also see that changes in the book, right? Because book is the same. There is only one book, right? So this you can understand it as call by reference. Is it clear now? Hope it is clear now. Okay. Yeah, you don't need to go in deep into this because this call by reference we are not going to use anyway. So this is just important with respect to interviews, right? So let's jump on to the next topic now. And yeah, Polymorphism. What is polymorphism? So polymorphism is another object-oriented programming concept. We have learned so far what is a class, what is an object, right? So we do have another four important object-oriented programming concepts. So the one of them is polymorphism. So what is polymorphism? So polymorphism is like one thing taking more than one form, or one thing taking many forms. So this is what we call it as polymorphism. One thing it takes many forms. This we call it as polymorphism. So examples are like if I say shape, right? Shape can be rectangle, square, right? Circle. It can be triangle, like that, right? And so on. So we have shape and it is taking different forms. Say for example, water. So water has different forms, right? So water has solid form, liquid, solid in the sense ice, right? Liquid and vapor. The same thing is taking at different times, it is taking different forms, right? So that we call it as polymorphism. So poly in the sense many, morphism in the sense form, right? Many forms. One thing taking many forms, we call it as polymorphism. So that's the definition of polymorphism. And a concept of polymorphism is overloading. Overloading, right? This is a concept which is related to the polymorphism concept. Right? So according to the polymorphism definition, this overloading concept has been introduced, right? So we can achieve polymorphism. So we are going to achieve this polymorphism using overloading, right? So how are we going to do that? Now we will see that, right? So as at a high level, you can think it of like polymorphism, one thing taking many forms. You'll understand that now when we see the examples, right? So overloading, we can achieve polymorphism. We can achieve polymorphism using overloading, right? So what is overloading? Say for example, I have some class called A, right? Now, so if I have a class called A, and say for example, I might have some variables. That's fine, right? So I might have some variables, and I'm interested to create some methods. Say for example, I create some method, right? Method called method one. So can I create the same method like this again in the same class? Method one. Can I create it or not? The same method in the same class with the same name like this? No. So we can't create it because it is exactly the same. It will be duplicate, right? So Java doesn't allow creating the duplicate methods, right? So we need to rename the method, right? But what if I can create the same method with the same name, but with a different parameters passed to it? So say for example, I take some parameter called NTA. So this we call it as overloading in Java. So this is possible in Java. We can create the same method. So we can create two methods with the same name, just differentiating with the parameters like this, right? So this is what we call it as overloading. This is what we call it as overloading, right? So why do you wanted to create this? Say for example, you know, you wanted to today I wanted to create some, so say for example a calculator. We are implementing a calculator, right? And we wanted to add two numbers. So what do we usually do? So what do we usually do? So we can write a method. Say for example, I can say add two numbers, right? So I can say add two numbers and pass two numbers to it. So that could be two numbers, right? Then what if I wanted to add three numbers? Then that's fine. I'll create three numbers. So I'll create a method called add three numbers and pass three numbers to it, right? And what if I wanted to add four numbers? I'll create another method called for. Say for example, like this, I wanted to add 10 numbers. You will create 10 numbers, right? It's 10 methods, right? Different methods will pass the parameters according to it, right? So this is how, as a developer, you are developing the code, right? Say for example, there is some user who wants to use your methods, right? Who wants to use your calculator. So if they wanted to add two numbers, then they have to know there is a method called add to, and they have to pass two numbers, right? If they wanted to add four numbers, they have to know that there is a method called add four, and then they have to pass the four numbers, right? So this is how it has to be used, right? The application calculator has to be used, right? Say for example, I have the same methods add two, add three, add four like this, but I'll have the same name. I'll have add. I'll pass two numbers here, right? I'll have add, but this time I'm gonna pass three numbers. Same add method, I'm gonna pass four numbers, right? So this is how I am developing. Whatever logic we are writing inside this methods, that will remain the same. But look at the naming here, name of the methods. So I'm naming the methods, all of them as add. So in this case, what happens? So as a user of this calculator application, it becomes easy for you, right? So you don't need to remember, even though you add two numbers, three numbers, four numbers, any number, right? So you can just call this. You just need to remember that you need to use the method add, and it's very flexible for you to pass any number of parameters or any number of numbers you wanted to add. You just pass that as a parameter to your method. You get the result. So this is simpler than the earlier one, right? So because it has different method names, though the definition inside this each of these methods is same. So instead of remembering like those names, all the names of those methods is bit difficult, right? So it's also tedious job, right? So instead of that, if we can have the same name to the methods, uh, this will be actually in the perspective of, in the point of view of developer, the effort will be the same, right? So the definition inside the method will be the same. The effort will be the same. But end of the day, whenever we are using this application as a user, you can directly use these methods, right? You don't need to actually remember all these methods. You'll just say add, and then you'll pass whatever number of parameters that application supports, right? But you'll always call only this method called add. This is more easy than the first case, right? So instead of this, we can use this one. This is more flexible and readable for the user point of view, right? So this is what we wanted to achieve using overloading. And this is all about we are talking about method. So we are having the same method name, which only differs in the parameters. We call this as method overloading. This we call it as method overloading, right? So same method name, but they differ in the parameters. So how are they going to differ in the parameters, right? So say for example, some more examples like we have seen calculator, right? Say for example, I wanted to greet people, right? So say for if there is one person, I'll just call his name. Hey, hi John is what I can call, right? Say for example, if there are two persons, right? So say for example, I'll say hey John and Mary, right? Say for example, there are more than two. So depending on the person or the count of the people before me who are meeting me, the greeting differs, right? So uh, here you have to concentrate like greeting is common, right? So greeting is a method. And then depending on the number of people, my message or whatever I'm seeing as part of greeting, that actually changes, right? So this we can consider it as an example for overloading, right? So in such case, what we need to do, we can have something called greeting as a method, and then based on the number of persons, number of people, we can actually modify the, based on the number of people we are addressing. So based on that, our message actually differs, but greeting is same, right? So this you can consider it as one more example for the overloading. So now let us take an example, then you'll understand better, right? So we'll take this example of calculator, right? Say for example, I have some application called calculator, right? And I wanted to add, so for just simplicity, we'll, we'll add two numbers. This is a calculator application, and I'm gonna create two class variables here. Say for example, I'll take something like this. Can we do like this? We can initialize the class variables also, right? So both are integer variables. I am creating two variables and also initializing them, right? Now I wanted to create a method called add inside this calculator, right? Calculator is an application, and I wanted to actually have this application add two numbers or some logic inside it, right? So say for example, I'm gonna add two numbers like this. This is perfectly fine, right? So we are just we have this method add, and we are having some logic written inside it. Now, if I the same method, what I'm gonna do is I'll repeat it, and I wanted to pass the data like this dynamically to this method and have that have the sum of these two numbers. So if you see here, I'm using the same name to the method, right? Same method to the same name to the method, right? I have already have a method called add. I'm using the same method name add. But if you see, we are differing it. We are making a difference by passing two parameters to it. So this is no parameters. This takes two parameters, right? So method overloading can differ in parameters. So for example, so we have to follow this. Methods have same name. Methods should have same name, and parameters should differ. So how are we making this difference in the parameters is by the number of parameters. So the number of parameters has to be different. Say for example, I have add two numbers, right? So you can even have add three numbers. So then Java differentiates between this add method and the parameter which takes two parameters. So that is on number of parameters. So you can see that here, right? So this method add. So are we following these rules? Method overloading. Methods have same name. Yes. Parameters can differ in number of parameters. That's true. So number of parameters in the sense this has zero number of parameters. It has two number of parameters, right? So it is different. So we are following these rules, right? Now, say for example, I wanted to, we can even differ the parameters using data type. So the same method we can repeat. Say for example, I wanted to add two numbers which are of decimal numbers. Then we can have it something like this, right? So parameters can differ either in number of parameters. Yes, number of parameters it differs when you compare these two methods. Now, when you compare these two methods, we can clearly see that though the number of parameters or arguments are the same, they differ in the data type. They differ in the data type, right? So say for example, I still have the same like this. At least what we can do is, say for example, this is int x and double y, right? So I'm passing two values, int x and double y, right? Now I'll have the same number. So if you observe, all the three methods have the same number of arguments, but they are differing in their data type. So the second rule has been applicable here, right? Now, say for example, I have the same, right? But I have the same number of arguments, right? Data type is also same, right? Data type of parameters is also like int and double. So I have two parameters, int and double, but I'm differentiating these two here by the order of arguments. If you observe, order of parameters is different. So we had int here as the first parameter and double as the second parameter. So in this case, we can differ it like we are accepting first parameter as double and the second parameter as y. So for now, forget about the logic, right? So whatever it could be the logic inside it. But how we are passing the parameters to the method. So that's all about the method overloading, right? So see, we have created how many methods? Like literally like 3, 4, 5 methods, right? So this is first method, second method, different variations, right? So we are creating different variations here. But if you observe, we are following this rule, method overloading rules. Methods have same name and they differ in parameters. And how do they differ? They can either differ in number of parameters or number of parameters. Clearly, we can see. So we have no parameters, we have two parameters here, right? So data type of parameters. So the data type. So data type is integer here, but we are taking double. We can even take the combination of int and double, right? And now we will have the same number of parameters and also we'll have the same data type, but in a different order. Order matters here. First parameter is integer, double here. But in this case, first parameter is double and the second parameter is integer. So at least we have to make the difference in one of these. So we have to show the difference either in number of parameters or data type of the parameters, or at least if number of data type of the parameters are same, fine. But at least we have to show the difference in the order of the parameters. So then Java will accept the same name, same method in this class, right? Now, say for example, if I wanted to add three numbers, so how do we do that? This again comes under number of parameters, right? Like this, we can create n number of methods, just showing the difference in the either number of parameters or data type of parameters, or at least the order of parameters, right? So one or more of this has to be applicable when we are actually creating the method overloading, right? Now, let's create a main method for this. And let's see how, right? So this is the main method and I'm going to create an object of calculator. Calculator is our class, which we just now created. I'm creating an object for calculator and then we'll call this methods. So once I create the object, C dot, when I say C dot, if you observe, all the methods are accessible, right? Of course, A and B are class variables, they are accessible. But if you observe the methods, so add is a, which is taking no parameters, right? So add double, you can see all the variations of the double, all the variations of this add method, right? So for now, let's actually call this add method, which takes no parameters, right? So if you see, 30 has been displayed because we already have two class variables defined here and we are using those variables inside the add method, which is taking no parameters. So this is the reason we can see this method has been called. So if you observe, Java is able to find this method clearly inside this class, right? It was able to identify that this is what it needs to call, right? Because we are not passing any parameters to this method, right? So this is the first method. Now let's call C dot add, and you have all these variations. You can choose any of these. So I'll choose both integers. Say for example, I pass it from 30 and 40. So if you observe, okay, let me run this. So if you see 70 has been displayed, right? So if you observe, actually what happened here, C dot add two numbers. So when we pass two integer parameters, so Java actually finds it like at the compile time, what it is trying to do. So it will identify which method it has to call. So it will search for all these methods and it knows these two are integers. So is there any method called add, which is actually taking two integer parameters? Yes, it does. So it does take two parameters, this method. So this method will be called, right? So that's the reason. So we are seeing the result here clearly, right? So in the same way, you can actually try all the other methods as well. I'm going to show you, one method like double. Say for example, I don't need to remember the class name. I'll always use add, but I can add any numbers like say for example 12.5 and 17.8, something like that. I'm adding here two double values, right? So in the same way, like which method this comes under? This one, third one, right? Say for example, I wanted to add one double value, and then one integer. Say for example, something like this. Even this is valid, right? So the sum of one double and one integer has been called, right? So where does this method? This is the method, right? This method, fifth method has been called, right? So in the same way, like so on, you can call any method, right? So you can call even. So I'm interested to add three numbers this time. So this time the last method will be called, right? So the sum of last three numbers has been displayed, right? So when we actually had the same name, it's easy for us to call the method. So, and depending on the parameters, like how the method has been defined in the class, so we can pass the parameters. So this is what we call it as method overloading, right? So this is what we call it as method overloading. We have to remember while doing while we wanted to achieve method overloading, the method can have the same name, but the method should differ in the parameters. So in that respect, so the number of parameters should be differed at least, or the data type of the parameters should differ, or if both data type and number of parameters are same, at least the order matters. So int double, right? So double int in this case, right? So at least we have to show the difference in the parameters in the order of the parameters. So at least one of these has to be satisfied to achieve the method overloading, right? And we can have a number of parameters. This we have already seen, right? So this is what we call it as method overloading. So one thing is performing many actions, right? So add is a method which is actually performing addition, but on in a different ways, right? So once it is taking no parameters but displaying the sum, right? So it takes two parameters of a different data types and it is giving the result, right? It can take three parameters and give you the same result. The method is same, but the action, whatever method we are using, that will be the same, but the action performed it will be different, right? Based on the input we provide, right? So let's actually create one more example. Let's understand with one more example. So say for example, I have some printer. So in this, I'm not going to take a new main method separately. Let's have it in the same class. I'll just say for example, I wanted to print a method. I wanted to print a document, right? So say for example, I'll have a method called void print, which takes a document. Document is string type, right? So now I wanted to print this document. I'll just say printing string document, right? Printing string document. Now I wanted to actually, this is a method to print a string, right? Now the same printer can be used to, say for example, I wanted to print some integer. Can I use it? Yes. Same printer can be used to print a integer. For example, say for example, some document ID, right? So it will take integer and a document ID. In the same way, say for example, I have some double value, right? This could be, an example could be some price, right? So if you observe, what are we doing here? We have the same method print, which is actually performing some action based on the input we are providing to it. So what's the input we are providing here? The input we are providing here is the parameter to the method, right? So if you see, the method name is same in all the cases, right? But the data type which we are passing to the method is different, right? So this is double. We'll just printing document with ID. right? And then this could be printing price. Let's call this as price. Yeah. So if you observe these three methods are doing the same action, print, right? But they are performing their own action depending on the parameter we are passing to it, right? So we are passing string here, we are passing integer here, ID, some ID here. Based on that, it is performing its task, right? So now in the main method, let's actually create an object for printer class. So this is an object. P is an object for the printer class. Now I'm gonna call this methods. Printer print, then print dot print of, or just not to have confusion, let's have the object name as P dot print of. Say for example, I'll just say hello world. Right? Now I'll call same print, but this time I'll pass some 1, 2, 3. P dot print, and I'll send some price here, right? So all are valid if you observe, because we have print method which takes string as an argument, which takes integer as a parameter, say, and also double as a parameter, right? So the respective method will be called. See, we have the right output, because when we call these methods using the object, this, even though the method name is same, so the corresponding method will be called depending on the parameter which we send, right? So in this example, all the methods have the same name. They differ only in the data type of the parameter, right? The number of parameters is same. All are taking the same one parameter, right? But they differ in the data type, right? So this is how you can achieve the method overloading, right? So same method name with the number of arguments should be different at least, or data type of the parameters should be different, or at least the order of parameters should be different, even though these two are same, right? So when you actually write following these rules, the methods, then we call those that as method overloading. This is called as method overloading. Is that clear? All right. I think it is clear. So this is called method overloading, right? So to give you another like other examples, so if we have payment methods, right? So once you go to some e-commerce application, say for example, and you add to cart some product, and then you wanted to make the purchase, you wanted to complete the payment, right? So when you wanted to complete the payment, so depending, you might have different options. You can pay using net banking. You can pay using credit card or debit card. You can pay using UPI app or mobile applications, right? So all these, depending on the application you choose, right? The payment method you choose, the payment process differs, right? So, but the payment method is same, right? So all are payment methods only, right? But based on the method you choose, right? The process actually differs, right? Say, for example, you click on credit card or debit card, right? Credit card slash debit card. So you'll be asked to provide the details of the card. Or if you actually choose net banking, you're asked to provide the bank name, right? So in the same way, like if you choose mobile application, it might actually provide you some mobile applications, right? So that differs, but all are the payment methods, right? So the same payment method. So all are payment methods. So we should consider here payment as a method, right? But the actions are different based on the input you choose. Input here is different methods of performing the payment, right? So that you can consider as the parameters. And another example could be like booking travel, right? So there are a lot of websites, right, which books travel for you. Like you can book a flight, and you can book a hotel in the same website. right? You can even book the restaurants or the whatever you wanted, right? Like along with the travel and you know along with the travel and flight tickets, you can also book something else like some resorts like that, right? So some nice dishes like that. All can be one package, or you can actually book only of them, only some of them, or you can even book the travel even without the flight tickets. Or you don't need to book the tickets, you can just book the hotel, right? So all those are possible, but everything is a booking, right? So you go to the website, you see like everything, all the variations are available. So you can book your travel according to your convenience, right? So that also comes under overloading. These are all like just examples to understand, but the overall concept here is having the same name. Methods will have the same name, which differ in the parameters, which only differ in the parameters, and these are the rules, right? So this is what we call it as a method overloading. So if you observe in all these examples, the same action is performed, but in a different ways, depending on the inputs. Depending on the inputs, the same action is performed, right? But in a different way. So this is all about method overloading. Now we'll see constructor overloading. So constructor overloading. So what is a constructor? If you remember, we don't need main method here. Constructor is also same like a method, which will have the same name as the class name, right? So say for example, this is a box which has like cuboid shape, and I'm gonna take double length, breadth, and then it will have height as well, right? So let's take height. So these are my class variables. Now I'm gonna create a constructor. So what do we call this constructor? This is not taking any parameters. So this constructor is called as a default constructor. And then I'm assigning some values to it. Correct? And this is height. So this is the default constructor where I am initializing what's the purpose of constructor? Whenever we say constructor, so we need to recollect. Like constructor will have the same name as class name. Constructor will not have the return type, and constructor is used to the main purpose of constructor. Constructor is used to initialize the class variables, right? So this we need to remember. So we can either do like this, or all the values are anyway same, right? So we can even have it something like this: length equal to, and breadth and height, everything is same, right? So you can even initialize like this as well, right? This is a constructor which takes no parameters, right? Now I'll create another constructor which actually takes parameters like double length, double breadth, and height. The same thing which we understood earlier, method overloading, right? Now we are trying to do this for the constructors. Constructors are also same as methods. Only thing is the name we can't change. So it will have the same class name, and it will not have a return type, and it is used to initialize the variables. This is the reason if you observe whatever we are passing, we are assigning it to the class variables, like whatever the parameters have been passed to the constructor. So that we are actually used to initialize the class variables here in this example, right? Here, for example, I'll pass only one argument. Say, for example, I'll pass only length. In that case, we'll consider that as a cube, and then we can just say, or okay, no return type, right? Constructor. So what we can do is length equal to, as only one parameter is passed, we can assign that to all the dimensions. I'll just say L here. This is not one, this is L, okay? Or let me call this as alien. Okay. So these are all different variations of the constructor. So if you see, this is a box is a class, and I want to create a constructor. So what did we do here? We are creating constructors, different constructors. So default constructor, why we are saying this as a default constructor? This is not taking any parameters, and we have initialized the class variables, class members here, right? So to 0. And we have another variation of the constructor which is taking three parameters of double type, right? And then what are we doing here? We are just initializing the class variables. So the main purpose of constructor is to initialize the class variables. That is what we are doing here in all the methods, right? In all the constructors, right? In all the types of constructors. So we are only showing the difference in the parameters. Like you can see, it is taking three parameters. This constructor is taking only one parameter, and so on, right? Now, so we initialize these variables, fine. So only initializing is not enough, right? So we initialize these values to these variables using the constructor. But in order to perform some action, in order to write some logic, where do we write the logic? In some user-defined methods, right? So we wanted to say, for example, we wanted to calculate the volume. I wanted to calculate the volume and I wanted to return it. So the volume will be of double type. So we need to mention this return type before the method name. So method names will have the return type. Even if you don't have the return type, then we have to specify void, right? So I wanted to return a value now, which will be double. I know it will be double. So I just mentioned the return type as double for my method called volume. And what I'm gonna return here, I'm gonna return length, length into breadth into height. So this is the method, right? So we initialize the values to the class variables using one of the constructors, and we are gonna call this method to calculate the volume. So I'm gonna create a new class. I'll call this as box main, where we'll have a main method in it. I have main method in it. So in order to call how do we invoke the constructors? So we invoke the methods by creating the object dot, right? We will have the object. Then we can actually call the method using object dot method name, right? But this is a constructor this time. So how are we going to call these constructors? So we do not call the constructors explicitly, but the constructor is called implicitly when we create the object. So constructor is called automatically during the object creation. This we have seen. Now I just say box b equal to new box. An object of box has been created now, and the object reference has been stored in b, variable b, right? Now, what happens with this? So which constructor gets invoked? So obviously the first constructor, right? Or whatever the constructor which is taking no parameters or zero parameters will be called, right? And then what happens within that? It is initialized, right? The class variables are initialized. Now we'll actually have the volume. We'll call using this object, we can call the user-defined methods, right? So only constructors can be invoked during the object creation. And that too, which constructor has to be invoked depends on the parameters you pass to this class, right? This box class. So we are not passing, in our case, we are not passing any argument. So this constructor will be called. So this will be the default constructor because this is not taking any parameters. So a constructor which takes no parameter, we call it as default constructor, right? So that will be called in this case. And you can see here. Okay, so we are returning it, right? So we are returning it. So we have to display this on the console. What we can do is we can calculate double volume. and then display it on the console, right? Yeah, it is 0 because length, breadth, and height, everything is 0, right? 0 multiplied with anything will be 0, right? All right, now let's create another object. So this time I'll pass some values, right? So some values like 15.5, right? 8, some values, right? Which are all double values. Now, which constructor will be invoked? Automatically, a constructor which accepts three parameters, which are double, will be invoked automatically, right? And the logic inside it. What's the logic? It is to initialize these values to the class variables. Will be so this will be done during the object creation itself when we are creating the object for the box, right? Box class. So this will be called automatically, and you know, whatever is inside will be the block of code will be executed, right? Now, once that is done, we have the length, breadth, and height initialized. And using the same object, we are trying to call the volume method. So volume method has to actually return the product of length, breadth, and height, right? So that is what it does. And we can see the output here clearly. So this is the product of these numbers, right? Now, for example, I wanted to create, so cube has all the dimensions saved, right? So I'm going to pass just something like this. So this time I'll just say this out, or let's get it here. This is a cube and I'm just passing one parameter to it. Do we have such method, matching method? Yes, we do have it. So we do have a box constructor which takes one parameter, right? Cube dot volume. So if you observe, so we this time as we are passing one parameter, this constructor will be invoked. So when a constructor with which takes one parameter is invoked, so we are initializing it to the same value which we are passing, right? Then we are actually calling this method volume. Volume method always returns the product of the length, breadth, and height, right? And that's what we are actually trying to print on the console. So you can see the product here, or the volume of the box, right? So what did we achieve here? It is also same as like method overloading, but we actually overloaded the constructor here. So we already learned the differences between method and constructor, right? So you can see clearly this is not the normal method. Though it looks like a normal method, this is a constructor because it has the same name as the class name. It has no return type, and it is mainly used here like to initialize the class variables, right? So this is what we call it as a constructor overloading. Constructor overloading. Is that clear? Okay. So now, so now we understood, like we have a good understanding on overloading, right? How method overloading works. Like in the same way, like constructor overloading works, right? So overloading is like the same action is performed in different ways, depending on the input or the parameters we pass to it, right? So this is all about the overloading, method overloading, right? And we have also seen the constructor overloading. Now, let us see one more thing. Like, can we pass parameters to the main method? Main is also a method, right? So can we pass parameters to the main method? Yes, we can pass parameters to the main method as well. So how do we do that? Let's see an example of it. Let's see that. So passing parameters to main method. Okay. How can we do that? So if you see here, this is what the main method is, right? So we said like this is the signature, and we should not change this because JVM identifies the main method because it needs the main method signature same as is to begin the execution from. So this will be the starting point, beginning point of the execution. That's how the JVM identifies. This is what we already discussed, right? So, and if you observe closely, so this main method is accepting one parameter. Now that we have a good understanding of the parameters, so I'm discussing this. So if you see here, this is a string. It is accepting, main method is accepting one string. It's not a string array. If you see here, right? So string array, and it's a name of the string array. So this could be anything like xyz abc, anything, right? So forget about this. Like say for example, this is some a, right? For now, or arguments. By default they give it as an argument, but you can even modify it as any other name, right? It's just the name of the string array. So this main method is accepting string array as the input. String array as the input. Now how do we actually pass this, like say for example, this is a string array, right? So we have the string array parameter. So we can actually use this string array inside the main method. So say for example, I wanted to print all the strings in this argument. So how do we do that? We can use enhanced for loop. If you remember enhanced for loop, we wanted to, if we use to read all the values in it. Now I am interested to read all the strings which are present in this string array called args, right? So I'll just use this and then we'll print all the strings within it to the main method, right? And also we'll just print the length of the array. How do we print the length of the array? Is dot length. Sorry, args dot length, right? So arg is the string array, right? Arg dot length gives us the length of the array. All right. Now, but how do we call this main method? So this is already usually invoked automatically, right? By the JVM. But this time we wanted to pass parameters to this main method. So this argument or this string array, so we wanted to call this main method explicitly by passing some arguments to this main method. So because this main method is accepting args, right? Args, which is a string array. So we can pass string array as the parameter to this main method. But how do we pass it? So we usually run it as run as Java application, right? So instead of that, so what we do is run as run configurations. We have something called run configurations. You can click on it and you can choose the main class here. So main class will be my pass parameters to main. So project class and then argument. You see something called argument. So here this is the place where we can actually pass the parameters. Say for example, I'll pass Selenium space. So the delimiter is space here. I can say Python, right? Ruby, something like this. That's it. And then say apply and run. Now you can see the output here. So those arguments have been taken by this parameter. So we call the main method and main method accepts some arguments. So we just wanted to see how that works. So we pass it some arguments, our own arguments to this main method, right? So it was a string array. Whatever you pass this with a space as a delimiter, those are the string array. So all those has been captured in the ARGS string array. Now, what did we do? We wanted to display all the strings. So we just use the enhanced for loop to do that. And also we wanted to look for the length of the array, like how many strings are there in this string array that we are interested that we actually displayed on the console, right? So if you wanted to actually, I'll show it again, run configurations. So you have to select here the in the main tab. you have to select project main class, right? Main class in the sense where your main method is, right? So that class you have to select, and then you can just do search and find it out here, right? And then click on the arguments tab and provide the arguments here, right? These arguments. You can even provide some other output like this, right? Welcome, C sharp. And then you'll just say apply, run. That's it. So it will take, so meaning all the arguments are passed to the main method, right? So this time it is, we actually sent, we actually passed 6 strings. So all those strings are captured as a string array, right? And we can see the length of the array clearly here. So this is just for your information that we can even pass the parameters to the main method, right? How do we pass the parameters to the main method, right? Now, can we actually overload the main method? Can we overload main method? This we have seen, this is here, right? Can we overload main method? Yes, we can overload main method as well. So what is overloading main method? Having the same name, main method name, right? So main method overload. We have the main method, right? So public static void main, right? Now, can we write something like this? Void main. And then can I have it something like this? Void main, which might take some integer value, right? Say, for example, it takes 2 parameters int y. Is this valid? Yes. So according to our rules of method overloading, this is correct, right? So main is also like any normal method, but following this syntax, it gets some special significance that the execution starts from here. JVM identifies with the signature, right? But if you see here, so we have main method here, and we even have the same void, right? But they differ by parameters. So this main method, the actual main method is accepting string array, right? So we are differing it using the different data type and also the number of arguments. Number of arguments are also 2 here, right? So in the same way, I can have 1 argument here like that. We can just say x plus y like this, right? So this is possible and this is valid as well. So how do we call these methods? Like again, in the main method, we create the object of the class, and then we do m dot main. See, we get the all the variations, which method you wanted to call, right? Say for example, I wanted to call this method, first method, second method. I can call it like this. So this is valid, right? We get the output. This is valid. So what did we do here? We wanted to overload the main method. So we have written main. We have taken the same name. So to overload the main method, so we have to overloading is having the same name to the method, right? So we use the same name for method main for the method, and then you can see we are passing some parameters to it. So we are showing the difference in the parameter type or data type, parameter data type, and also the number of arguments it is accepting, right? So this is valid. Can we overload main method? Yes, we can overload main method. This is again one of the interview questions, right? One of the important interview questions. So can we overload main method? Yes, we can overload the main method, right? Can we pass parameters to the main method? Yes, we can pass parameters to the main method because the default main method, it accepts the string array, right? It accepts the string array, right? So we can pass the parameters to the main method. And we can even overload the main method as well, right? So you have to remember the overall overloading concept is simple. We can have same name for the method and the number of parameters or the input we pass differs. And in all the examples, if you observe, like this return type doesn't matter. Say, for example, I can't have the same method like this with return type, with differing only return type, right? So if you observe, these two methods are same. Both are have the same name. It is also accepting the same parameters, same data type, same order, right? So they differ by the return type, right? But still, this is not valid. JVM considers both as the same method. It considers it as duplicate method. See, it says duplicate method main int in type main method overload, right? So return type is not considered to differ in the method overloading, right? So only this rules applicable, right? It has same name and differs by number of parameters, either by number of parameters or data type of parameters or the order of parameters. One or more of these conditions, right, has to be satisfied in order to achieve method overloading. So mainly in this session, we have discussed about call by value, call by reference. What's the difference between these two? What is polymorphism? How we can achieve using like we have taken overloading, method overloading. So to understand the concept of polymorphism, right? Overloading is a concept based on polymorphism, and we understood method overloading. We have seen examples on constructor overloading as well, and we have seen like on the main method, can we pass parameters to the main method, and can we overload the main method? So is that clear? Any questions on today's session? Is everything clear? Okay, I take it as is. I'm stopping here.